Hey everybody, chemistry students, this video is to help you out, help you complete the molar mass of a gas portfolio. This portfolio is from Unit 1, Lesson 9 Teacher Notes. Please make sure you're reading your teacher notes as you go. If you are a pre-AP chemistry student, this video does not pertain to you. Please make sure that as we go through here, notice that the numbers on my examples are different from the ones that you need to complete on your portfolio. This is simply to help you set up the problems and solve them correctly. Your numbers will be different. That's your disclaimer. Make sure you have a calculator and something to write with here. So your page should look a little something like this. The very first question that you have here, well, both of these questions are stoichiometry problems, so that's why you see the mole roadmaps at the top. This is information that we ended first semester with, and it continues into second semester. The first question here says, based on the equation below, how many liters of water can be produced from 6.25 liters of oxygen gas? Assume that hydrogen is in excess. What this is saying is that out of your two reactants, you're going to have more than enough hydrogen gas. The limiting reagent, the thing that's going to be used up, is oxygen gas. So the question wants to know what volume of water can be produced. Notice that there's a G next to the H2O. Okay, it's actually in the gas form. Okay, that's why we're using the gas laws in order to solve this problem. On your mole roadmap, you probably have noticed before that there's this part of the roadmap we haven't used before, and it says volume of a gas at STP. This is the relationship between moles and the volume of any gas at STP. You may not be able to see it very well on my screen, but if you look at your portfolio, it gives you the number that you need to know. 1 mole of any gas at STP occupies 22.4 liters of volume. That's the number that's being represented in this relationship here. 1 mole of any gas at standard temperature and pressure occupies 22.4 liters. Okay, so getting back to our problem, remember you always start with what you're given. The problem tells us that we have 6.25 liters of oxygen gas. So that's what I'm going to start with here. On my mole roadmap, that would be equivalent to starting right here. Okay, it wants to know how many liters of water can be produced. Okay, so liters of water is going to be my product. So I want to end up at the volume over here. Okay, well, follow your roadmap. How do you get from liters of one gas to liters of another? You're going to start by converting to moles. Your next step is to do a mole-to-mole ratio to convert to moles of the new substance. And then your last step is to convert to volume of that substance. Okay, those are our steps that we're going to write down in our problem. Starting with 6.25 liters of gas, my first step is going to be to convert to moles of oxygen gas. So liters is going to cancel out on the bottom. That's why I have 22.4 liters down here. Remember that came from my mole roadmap. Over 1 mole. 1 mole of oxygen gas will occupy 22.4 liters. My next step, convert from moles of one thing to moles of another. I have moles of oxygen and I want to convert to moles of water, my product. So I do a mole-to-mole ratio using my coefficients. The ratio of water to oxygen is 2 to 1. No coefficient means that it is an understood one. So that's where this ratio comes from. My last step would be to multiply by 22.4 liters because this gas is at STP. Okay? Alright, now I'm going to plug this into my calculator. When I do that, I take 6.25, again, always start with the number that you're given. My next step is going to be to divide by 22.4 liters. Then I'm going to multiply by 2 because it's on top. And then my last step will be to multiply by 22.4 liters. Pause the video now, plug that into your calculator, and see what value you get. What answer did you get? Hopefully you got an answer that looks like mine, 12.5. 12.5. What's my unit? Look back at your problem and make sure that everything cancels out except for the unit that you're solving for. Liters of O2 is on the top and it's on the bottom, so liters of oxygen cancels. Moles of oxygen is on top and the bottom, so that cancels. And then moles of water is on top and the bottom, so those cancel as well. So the unit that I'm left with is liters. You should have gotten 12.5 liters of water. The next problem. It says to balance the equation below and answer the following question. What volume of chlorine gas, measured at STP, is needed to complete the reaction with 8.5 grams of sodium metal? Start by balancing your equation. I always like to list the elements underneath the equation first. My next step to balancing the equation is to take inventory, count how many I have on both sides. In my reactant, I have 1 sodium atom and I have 2 chlorine atoms. In my product, I have 1 sodium and 1 chlorine atom. So to balance this, I'm going to start with chlorine. I need to add a coefficient of 2 to my product, and it looks like this. 2 moles of sodium chloride, which means that in the equation, I'll have 2 sodium atoms and 2 chlorine atoms. Now my sodium isn't balanced, but by adding a coefficient of 2 to my reactant, now I have a balanced equation. I have 2 atoms of each element in the reactant and in the product. Now I can solve my equation. Okay, it says balance the equation below. Check, did that. What volume of chlorine gas measured at STP is needed to complete the reaction with 8.5 grams of sodium metal? Okay. So they have given me, let's see, the mass of sodium. I know the amount of grams of sodium I have. What they want to know is how much chlorine, excuse me, will I need in order to use up my sodium? Always start with what you're given. Okay, they gave me 8.5 grams of sodium. Okay, look up at my mole roadmaps for a second. They gave me mass of one of my reactants, and I need to solve for volume. So I'm going to go from mass to moles to moles to volume. Those will be the steps that I set up in my problem below. So first, I take the mass of sodium, and my first step is to convert to moles by dividing by the molar mass of sodium. I got 23 from my periodic table. My next step is to do a mole-to-mole ratio. The thing I'm solving for goes on top. The thing that I am going to cancel out goes on the bottom. So I need the ratio of chlorine to sodium. And understood 1 and a 2. So my ratio is 1 to 2. And then finally, my last step, as I'm converting to volume, since this gas is at STP, it's going to occupy 22.4 liters per 1 mole. Now plug this into your calculator. Take the mass you're given, divided by molar mass, divided by 2 moles, times 22.4 liters. Pause the video, plug this into your calculator, and let's check our answer. When I plugged this problem into my calculator, the answer that I ended up getting is 4.14 liters of chlorine gas. I have 4.14 liters because grams of sodium canceled out, moles of sodium canceled out, and moles of chlorine canceled out as well. So I'm left with liters of chlorine gas. Check your answers. If you got both answers right as we went through, great job. You're ready to complete the portfolio on your own. If you did not get those answers and you still need more help on the portfolio, please contact me. Call, text, or webmail, and I'll be happy to help you complete your portfolio. All right, one more time, make sure that you check your numbers. The numbers that I used in this example are different from the numbers that you have on your portfolio assignment. All right, good luck. Turn it into the Dropbox when you're done. Have a great day.